video, we are covering Section 7, Feasible Regions. So as we've discussed in class already, a feasible region is the set of all points that satisfy the constraint for the problem. In other words, that is where the shading overlaps. So when we have a multi-part, a large word problem, and we write inequalities for those word problems and we graph them, this is an example of a feasible region of an activity. So this activity was called Healthy Animals, and so we had three inequalities here, and where they overlap is this area in the gray. And so this area here is the feasible region. You want to point an arrow to that area. Well, I guess it was already typed on there. Okay, so once we have a feasible region, we know that the solution for the problem is going to come from this area, okay? And along with the feasible region, the next idea is what is our objective, right? So our objective is a linear function representing cost, profit, or some other quantity. So we've talked about spending at this much money. We've talked about having this much time. We want to make this much money. So we have all of these objectives that we've been focusing on. And so, for instance, let's say that this problem here has an objective of dog food, okay? So we have, or pet food. And so food A is costing $2 per ounce and food B is costing $3 per ounce, and we want to spend $24. So if I want to expend exactly $24, this would be my objective. $2 times each A plus $3 times each B. This is my objective equation. And so if I wanted to observe this equation on my feasible region, well, this is something that's written in standard form, we could then graph it by using intercepts. So if I plugged in 0 for B, I would have 2A equals 24. Divide both sides by 2. The value of A is going to equal 12. If I plug in 0 for A, I would have 3B equals 24. Divide both sides by 3. The value of B would be 8. And so if I go back to the feasible region here and look at my graph, I'm going to be at 8 here on the y-axis and 12 on the x-axis for a food A versus food B, and I could draw in this line. And so that is then my objective. I'll go ahead and extend this down. So this is my objective line, okay? And so the question is then, like, if I wanted to spend exactly $24 and meet the restrictions, I would have to have an ordered pair on this black line inside of the feasible region. So what if I wanted to spend the least amount of money possible, right? Well, I would simply slide this line down the graph, and I would know that this corner that I just touched would be the cheapest corner. If I wanted the most expensive combination, I would slide my line up the graph. Okay, my graph wants to drag, so I'll just drag it. Well, maybe I shouldn't drag it. I'm going to go ahead and grab that line again because that angle might change if I'm dragging the graph. So let me see if I can grab that line. There we go. And if I drag this line up the graph, which corner do I hit last? It's going to be this corner up here at the very top. Okay. And so that is going to be the corner that I pay the most amount of money for would be in the top corner, and the least amount of money would be here. So let's continue on here, and so that is established here. So again, the solution to a linear programming problem is going to be when you maximize or minimize. It's always located on a corner of the feasible region. So I have a few examples for us to check maximizing and minimizing. So again, once you know what that profit line is, you can add it to your graph and look for it. So on example number 1, it says in a feasible region and a profit line shown, a feasible region profit line is shown below. Circle the point that maximizes that situation. So if you take a ruler or a pencil and you slide it up the graph and you look for hitting the very last point, I'm going to go ahead and add a line that is movable. So I'll add it so it's the same slope here. Just extend it out. Didn't quite get the same slope. It moved on me. Let me fix that. Okay. So now if I drag this line, there goes the picture again. Hopefully you're enjoying my commentary during this video. Okay, let's grab the line. And I drag this line across my feasible region. I can see that the last point that I'm going to hit is just barely this corner here. I've already passed this point, okay? And so the last corner that I would clip would be this point out here. So this would be maximizing the solution if I'm taking the slope away. So let me go ahead and put this point over here. You can probably guess on this one, this is a very vertical line. And if I drag this line across my slide here, all the way across, point down here on the x-axis would be. So some of us think that this point, some point out in the middle is always going to be the solution. Sometimes it's a point on the axis. It just depends on whatever the objective or the profit line is, okay? And so as we're going through here, we have example number C. This line is very horizontal, and if I drag this line up the slide, you can see then that this point is going to be the last point that I touch. And then the last example, number 2, if I have a feasible region and the cost line is shown below and I want to minimize the cost, I would take this line and drag it down. The very last corner I would touch would be this one here. These two are obviously horizontal from each other, but with this line, I drag it down. This is going to be the last point that I touch. So that concludes our Section 7 notes.